All right, well, welcome everybody. My name is Lindsay. I am so excited to see you all here today.
Hi, everyone. I'm also excited to be here with you today. My name is Cindy. Hi, Lindsay.
Hi, Cindy. Good morning.
Good morning.
So, we are connecting with all of you. Some of you are connecting with us on Zoom, some of you are connecting with us on YouTube. Just so you know, this is our virtual classroom, and it may look a little bit different than the classroom that you've been traditionally doing when you connect on your computer. And that's great. Just so you know how we're organized today, right now, you're only ever going to see Cindy and I on the screen. That's because we have about 1,000 different student scientists from around the country logged on today, and that's just too many tiles on the window.
Yeah, it's super exciting that we get to do this with so many students, Lindsay. I'm really excited to get started on session 1 of our Coastal Redwoods program.
Yep. And just to orient you all, if you do have questions, you can go to the link in the chat box for the Mentimeter, and that will be able to help you. You can put the questions in there, and we'll answer them as fast as we can. All right, so let's go ahead and let's introduce where we're coming from today. Now, I know some of you are really familiar with our location. It's the California Academy of Sciences. It's a big museum in the city of San Francisco. And right here you can see our building in Golden Gate Park. It actually looks like it's part of the park, and that's because our museum, one of the things that we love to do here is to explore nature all around us.
Yeah, and it's a really fun place, and we get to come to you live. I know Lindsay is at the California Academy of Sciences. She's actually right outside of our museum, and I'm coming to you live from my home, and we're very excited to be with you here today.
All right, so some of the things that we're going to be exploring today are trees. And they're one of my favorite organisms on the planet. I just love trees. And I know that some of our students at home have been exploring trees as well.
Yeah, it's been really neat, Lindsay, to see some of the work that has come up on our Padlet. And it's really interesting to see the variety. So you've been looking at different trees around your home. So here we have some of those sketches that we noticed. And we got so many sketches and we got to see all of those. So thank you for putting those up and continue exploring. But here we have some sketches, and it's really neat to see some of those details, that information that you were observing, and even looking at more like closely at some of those patterns that the trees around you have.
Yeah, and if you didn't get a chance to explore trees beforehand, I know after today, you're going to have some ideas of how to explore, and we definitely encourage you to explore trees near your home too. So Cindy, we're talking about trees. What is a tree? What are some ideas about what trees are? Did you get any responses from students kind of sharing
Yeah.
that?
Why don't we take a look, Lindsay, at some of those responses from students, and I can share those results. So it looks as we were looking at our Mentimeter, and some of them are still coming through. I noticed, Lindsay, that leaves, branches are some of those things that are coming up, as well as roots.
Yeah, and I see some people kind of talking about how trees are tall.
Right.
Maybe some of the things that they notice are like textures. I see the word rough popping up on there.
Yeah, I'm also seeing some really some different responses, such as like helpful, like they might be helpful. So that's interesting to see, and yeah, I'm curious how that might come to play into our sessions today or
Yeah.
moving forward.
Yeah, that's really interesting. Thank you, everyone who was able to contribute. We're going to be using Mentimeter throughout our sessions, so that's just one of the tools that we have. All right, so we kind of talked about like what a tree is. I think it might be time for us to really begin to meet the trees that we're exploring. Yeah?
Yeah, and Lindsay, what trees are those?
That's a great question. It's called redwood trees. We're going to be exploring redwood trees, and they happen to be right here behind me. And one of my hopes is that today we're going to be able to really learn a lot from them. So I'm going to go introduce myself. Hello, tree. It's nice to meet you. Can you tell me some of your secrets? How did you get to be so big? How big are you?
Now, Lindsay, I have the same questions as you, and I know some of our scientist friends at home do too. But can the tree really tell you that right now? Are you
No, of
are you
course.
talking to the tree?
I am talking to the tree. It is not quite talking back to me though.
Ah,
But it's one of the interesting things. In order to like really unlock secrets from plants and animals around us, we do have to learn to speak their language to a certain extent. And what that means is it means that we have to look at them through the lens of being a scientist.
ooh. Lindsay, I have what we call a scientist pledge. Would it be okay if we took that together today?
That sounds perfect. Thank you for offering.
All right, so I want everybody at home or wherever you may be to raise your right hand and repeat after me. Today, I'm going to be a scientist,
Today, I'm going to be a scientist,
which means that I'm going to observe closely.
which means I'm going to observe closely.
I'm going to jot down my observations
I'm going to jot down my observations
to unlock the redwood secrets.
to unlock the redwood secrets.
Thanks, everyone. Thanks, Lindsay.
All right, so Cindy, thank you so much for sharing that. So maybe we can start out with this idea of observing things really closely, because you said that was something that scientists do. All right, so why don't we go ahead and take a really good look at some of our trees. So maybe what I'll do is I'll just hold my camera over since I have the redwoods here.
Okay.
And as we go through, what I'm going to do is I'm going to kind of scan the trees from bottom to top. And we'll just have a moment to kind of quietly observe the trees. And at home, the other thing that Cindy said was to jot down what you notice. So maybe you jot that down in the form of words or sketches, but jot down some of the things that you notice about the tree. And if it's helpful, you can even think about the kind of sentence frame of like, ooh, I notice or I see, and then maybe make a list of the things that you see, whether it's colors, textures, parts of plants, those sorts of things. All right, here we go. All right, so we had an opportunity to look at those and to kind of be with those trees. Sometimes I like to kind of stretch tall like a tree. Go ahead and stretch with me if you like. And extend your arms out like branches. So I noticed that kind of tall and noticed the branches on the trees. What did you notice, Cindy?
As you got really high up, I also started seeing those leaves that were on the branches.
Ooh, yeah. There were a lot of leaves. There were so many leaves, I couldn't actually see the top of the tree.
Yeah, it's a really tall tree. Like those trees, I noticed you had to kind of back up and tilt your camera as well.
Right. Yeah, I had to kind of back up and tilt my camera. And the trees are pretty far away. I know you saw me shake hands with the tree, but like if I go and stand next to the trunk just to give you scale.
Lindsay, you look so short.
I know I'm really short compared to a tree. But you know what's really amazing, Cindy? This is a baby redwood tree.
Wait, that's a baby redwood tree. You look so short, and you're taller than I am, Lindsay.
I'm 5.5 feet tall. So I'm not very tall, but
But
still,
a
I'm
little bit
not
taller.
I'm not very short either.
Exactly. So if that's a baby tree, are you saying that there are bigger trees than those, bigger redwood trees than those?
Yeah, it's interesting. That's a really good question. And you know what? It reminds me, we also had some questions from students that were shared with us. And I wonder if we could just take a moment and kind of look at them, because as we explore today, I want to try and see if we can kind of answer some of those questions.
I love that idea.
All right, so let's go ahead and we'll hear from a couple of students. Oops, hang on a second. I forgot to share my audio. Okay, let's try that again.
Why are redwood trees called redwood trees?
For some reason, I'm not hearing it, but that's okay. So right now I'm hearing, why are redwood trees called redwood trees?
I was able to hear it, Lindsay.
Oh, good.
Yeah.
Great. Okay, so let's hear question number 2.
Hi, my name is Shivani, and my question is, how tall is
How tall is a redwood tree?
Hi, my name is Matea Marshall, and how wide is the biggest redwood? Thanks.
Yeah, thanks everybody for sharing these questions. I know many of you had very similar questions. I did too. So thanks for sending those over.
Yeah, so what we're going to do is we welcome questions. So part of being a scientist is being really curious. And so please ask us lots of questions. And every week we're going to try and answer some of the questions that you have. So here were some of the ones that were submitted this time. And we're going to definitely try and answer those questions, and maybe some even more of them. Okay, so the first question, somebody wanted to know, there was kind of 2 questions that went together. How tall and how wide are these trees? So I kind of combined this, and we're going to talk about giant. Like when we talk about giant redwoods, how giant is giant? Can you think of anything really tall, Cindy?
A giraffe is really tall. I think of giraffe.
They are really tall. I seem to remember that giraffes are at the tallest giraffe is probably about 20 feet tall. So that's like a 2-story building.
Mm-hmm.
So let's kind of think about this. I think we might need to choose something a little bit taller. So let's go ahead and let's look and kind of compare, thinking about a 10-story building. So this would be 5 giraffes tall. Okay, so how tall are redwood trees? Now these ones behind me, I said they're babies. So let's visit a grandmother tree. And to do that, we're gonna have to kind of go virtually. So we were able to get these really cool photographs from National Geographic. Okay, so here is a 10-story building.
So Lindsay, when I look at that, it looks like there's more to that tree.
Yeah, so let's span up. Let's do another 10-story building on top of that.
Is that the top, or is there more?
Here's the next 10-story section.
Okay, that has to be the top.
Well, we still can't see the very top, right? So let's do one more just to see how it compares.
Whoa. Wait,
Yeah.
you did this 4 times. So 4 10-story buildings?
Yeah, so the tallest redwood tree, which is the tallest tree in the entire world that we know of, is 380 feet tall, or about 38 stories tall. It's like a skyscraper.
Secret unlocked.
Okay, so now another question was like, how wide can they be? So I did a little bit of research, and I thought, since we're talking about giant trees, let's compare the width to my favorite giant. This is Andre the Giant. And he is somebody who is almost 7 feet tall. So like that's higher than I can reach my hand. But he was almost 7 feet tall. So how many Andre the Giants would it take to stretch across one of the widest redwood trees?
All right, everybody at home, think about that, or wherever you may be, think about that for yourself. Lindsay, I'm going to say 3 Andre the Giants.
3 under the giants. That's a really good guess, Cindy. It's about 4 under the giants. So the widest tree that we know of for coastal redwoods is 30 feet across. So that would be if you laid 4 giants in a row, that's about 30 feet across.
It would take so many people to hug that tree.
Right, right. So many people. So
well, that was definitely a question that our scientist friends had. So thanks for sharing that, Lindsay.
yeah. I also, I like to look at statistics, and I noticed when we were looking at our word cloud
Mm-hmm.
and what makes a tree, I noticed some students wrote in the word roots. So
Yes.
one of the things that I was thinking about is if this tree is so tall and so big, like it must have a really stable system, right? Because otherwise it might just like topple over.
Yeah, I completely agree, right? To keep it very stable.
Yeah. So I can't really show you, like the roots are underground, so I can't really show you that. But what I can tell you is that scientists, they've used some different tools to map how far redwood roots extend out. And it turns out about 100 feet. So one 10-story tall building, you turn it on its side, it extends out about 100 feet in every direction. And not only that, their roots reach out with all the different pieces and they grab onto other tree roots. So redwoods actually become stronger when there's more redwoods around them because they can grab onto each other and help hold each other up.
That is another secret unlocked, and I like how they hold on to each other. I like this idea of being together.
Right. Yeah. I mean, I feel like that's what friends are for.
Exactly.
Okay, one more little thing. Some of our friends at home know that science museums, they have collections. And in those collections, they have things of all different types. And it's often things that are similar that we put together. So I pulled out a tray of some of our collections of cones, like, kind of like pine cones, but there's
Right.
like redwood cones and pine cones and fir cones and all those sorts of different things. So we're going to talk about how giant are redwood seeds. How giant are their cones? So take a look at this. This is just a little guessing game just because it's fun. If you were to guess, and scientists at home, think to yourself, which one would you guess? If you're in a classroom, you can go ahead and hold up the number of fingers that you think match the cone that goes with it. Cindy, show me on your fingers, which cone do you think? You think it's number 1. Yeah, it's a huge pine cone. That pine cone is like this big. Well, it turns out I was able to get some off the ground this morning, but it's actually cone number 7. So I'll put my hand behind it so you can kind of see the details of it.
So you're telling us that the smallest one in that collection tray is the one that belongs to the redwood tree.
Right. And so we can look at the details here. And you notice how there's like little pieces of the pine cone? Those are called scales. And in between each scale is where the seeds are. Now, this is a pine cone that's already released its seeds, but there was once about 100 seeds in here. So if you think about that and how little this pine cone is, these giant trees come from itty bitty teeny tiny seeds. And I find that fascinating.
Another secret unlocked for sure. One that I wasn't thinking of, but it's super cool to think about hundreds of seeds. Wow. Well, what are some of the other things that we can learn by looking at a redwood tree, Lindsay?
Well, that's really interesting. So I was talking with some tree scientists, and one of the things that I learned is that scientists, they like to look for patterns. So we kind of have this idea of like the scale of a redwood tree and how big it is,
Right.
but we have to look for patterns across multiple trees of how they're similar, how they're different, to get a sense of what kind of defines a certain species or type of plant. But then also kind of thinking about some of the variation within there. So we're going to look for patterns. Okay, so let's see here. What I'm going to do is I'm going to put up a picture of a bunch of the old growth, the kind of grandfather, grandmother redwood trees. And I want you, let's just take a quiet moment and let's kind of look at this. And scientists at home, you can jot down, or maybe just think to yourself, how would you describe the patterns? What patterns do you notice? All right, Cindy, so what did you notice?
So I was looking at these trees, and what I noticed is that there's the trunk that goes really high. It's a really tall tree in this case, or all the trees are really tall. And they're starting to show up, like leaves are starting to show up, but it gets bushier at the very top.
Yeah, I noticed that too, right around this kind of like 200
Yeah, like a
foot
200
zone.
feet. Yeah.
It looks really bushy, kind of like a Christmas tree.
Yeah.
To me. But yeah, they're more bushy. And then below that, I was noticing there are branches, like really low down. There's not a lot of branches, but then there's kind of like, I don't know how to describe it, like kind of that pattern of like a branch and then a gap and then a branch and then a gap. Yeah, so it turns out scientists notice these patterns too, and just so that it would help them when they talk about trees, they gave them names. So the top part, the really bushy part, is called the upper canopy. The sub canopy is this area where it's kind of, you know, that pattern of branch and like and gap and branch and gap. And then there's the understory and the forest floor. And those are these kind of areas down here. So yeah, so those are kind of the patterns. And so what we're going to be looking at and what we're going to be thinking about today is this idea of what can we learn by looking at these different portions of the trees. And to do that, we're going to do some sketching. So scientists at home, get out your paper, get out a pencil. And what we're going to do is we're going to sketch. And we're going to sketch a tree on one side of the paper. And try and orient your paper this way so it's long ways across. And we're going to draw a tree on this side because then what we're going to do is we're going to fill in this information.
Yeah, and we're going to be using this sketch throughout our different sessions. So we're going to make sure that, like Lindsay said, so on one side of the paper, we're going to focus on just now. And we'll get to use this and jot down our observations. More observations today and throughout our series.
All right, so Cindy, one of the things about scientific sketching and this particular type of scientific sketching is it doesn't have to be pretty, but the idea is that we're trying to capture information that help us understand something new. And so part of that is being able to look closely at the trees and then to be able to kind of sketch it. So what we're going to do is we're going to sketch a representative tree. It's like just one representation, and later we're going to add information to it. So remind me again, what was at the top of the tree? What were the things that we kind of looked at?
So we were looking at how the leaves at the top of her tree were really bushy. And I remember that you mentioned it kind of reminded you of a Christmas tree. So it was really bushy at the top, at the upper canopy.
Okay. Right. And then down low, it was just kind of like a bare trunk, right?
Right.
Okay. So scientists at home, you don't have to draw what I'm drawing. Draw the tree that you remember. And the whole point is we're just trying to capture for a moment some of these different pieces. So what I'm going to do is I'm going to keep doing my sketch on my paper, and you can do yours and keeping that tree off to one side. And then I'll put up the pictures of trees so you can pull out the details that are interesting to you. Oh, and one thing I forgot to mention is you can add labels to it. So I'm going to write upper canopy, sub canopy, understory, and forest floor, just so I can kind of keep track of them. All right, scientists, go ahead and take about 30 more seconds. Once again, this is just kind of just a quick capture, and you can always add to this later.
So Lindsay, I noticed that there are different layers, right?
Mhm.
We looked at all the different layers within this redwood tree. I wonder if it would be if it's something that we can actually look at a little bit closer, like those different layers.
Yeah, that's a really good idea. And I love that you asked that because when I was talking with some of the tree scientists who do this a lot more than I do, we were talking about, especially with something that's so big, it's really good to kind of look piece by piece. So what we're going to do, scientists at home, is we're going to go layer by layer from the forest floor up, and we're going to be noticing two things: what patterns exist in the trees, and then also what patterns exist in the forest around the trees. So it's not just the trees, but it's also the other things too. So we're going to look for two separate things. All right, so here we go.
All right, so scientists at home, take a look at these trees in the forest floor and the things around them. What are some of those patterns that you notice?
Cindy, I noticed that there's some kind of dark colors on a lot of these trees, the big redwood trees.
Yeah, I also noticed that too, kind of towards the bottom, right? Like in that forest floor bottom piece of that redwood tree. Lindsay, I also noticed in one of the trees, where there's this really adorable little girl that I know you're familiar with.
Yeah, so that's a picture. I went hiking with my daughter in Muir Woods, and she liked to go into she called them tree caves, these kind of caves
Yeah,
in the trees. Yeah.
yeah. So that's a really interesting pattern to some of these trees,
Yep.
and all those different leaves, the different plants around at the bottom at the forest floor.
Yep. All right, scientists, let's go ahead and look at some patterns of the sub canopy.
Well, this looks different for sure than the forest floor.
Yeah.
I don't know if you noticed, Lindsay, in these photos, we're seeing those trunks, right? Like that really tall. It reminds me of your drawing, actually.
Yeah, the trunks that are up there. And then I noticed that there are shorter trees with more bushy parts
Yeah.
that are able to kind of grow where the sun's shining in them. All right. Well, let's think about patterns in the top of the trees when we're getting up to the upper canopy. And to do that, I thought maybe what we would do is we would just kind of take a look really quick at how scientists get up there, because as we remember, we weren't able to really look up and see the top of the trees that I'm at, and they're just babies. So it turns out the scientists have to go up there, but like operating a drone,
Hmm.
they can do, but there's a lot of branches, so it's hard to see where to point the drone at to go. And likewise, if you bring like a helicopter to the top of the trees, it just, you know, it's hard to see. So they actually go up into the top of the trees, and they do it by climbing.
And look at all the different equipment that this scientist is wearing or using, right? Like there's a helmet, of course, to stay safe. There's a rope and all this other equipment. Lindsay, I was thinking about you when I saw this video because I bet you could do it.
I would love to do it. I don't know if I could, but I would love to. I think it'd be super fun. Okay, so when scientists got up there, and they only started climbing trees just a little while ago, they were surprised to see some patterns that they hadn't noticed from the ground. And what they noticed is that there were a lot of trunks. Like there was like a main trunk, but then lots of trunks that kind of seem to just go off from the different sides.
Yeah, I'm noticing that too. So something new about redwoods that we're noticing, right? Like we looked at our redwood tree earlier and we drew one trunk, like we sketched one trunk.
Hmm.
So what if we were to call that out onto our sketch?
That's a really good question. So one of the things that we can do with scientific sketching is we can put kind of an arrow and we can add a few more details. So I can either kind of just add more details of showing those different trunk patterns, or if I want to and prefer, I can kind of add in words. And I'm going to add in a question because I'm really curious about this. Why do redwoods have so many trunks in the canopy?
Yeah, I like how you added that, right? Like some of the information that you're noticing, but also writing down questions you have as you're sketching.
Right, yeah. And those are what's really good about kind of making these observations is we can keep adding to them, and then that will lead us into asking more questions potentially, and that's how we're going to get at least 3 series out of this. Okay, so there's something else in the canopy though that's really fascinating that scientists discovered.
What did they discover?
Believe it or not, this is from about 300 feet up in the canopy. So this doesn't look like redwood to me. Does it look like redwood to you?
No, it doesn't. It actually reminds me of the plants that were at the bottom on the forest floor.
Right. So it turns out that because these trees are so big, you know, like some of the biggest trunks can be like 9 feet across, that in the fall and throughout the year, when redwoods drop lots of leaves, like the ones that are all over the ground right now,
Uh-huh.
they drop and they land on these big platforms. And then over time, soil builds up and other plants are able to live off of the redwood tree. It's like a whole other forest up in the redwoods.
So if it's a whole nother forest, what else can we see up there?
So you can see all sorts of things. There's animals like the salamander on the right. It turns out it spends its whole life up on the top of a redwood tree. Owls, nests. These are huckleberry plants. Some of the scientists talked about climbing, and when they wanted a snack, they could just snack on the huckleberries that were growing in the tree.
Very convenient.
Yeah, so it's super fascinating. And so these trees and the way scientists learn about them, that's what we're going to be focusing on as we go through the rest of our sessions. Now, I know there's a lot of questions that we didn't necessarily have time to unlock the secrets to. So one of the things that we're going to do, scientists at home, is we are going to be unlocking more questions next week.
Yeah, we definitely unlock some of those secrets, but there's so much more we can unlock from our redwood trees.
Right. So some of the questions that I know we have already been asked by students is, why do trees only grow in California, or do they? Mm-hmm. How long do redwood trees stay alive? And so what we're going to do is, scientists, you're going to have an opportunity to share your questions with us, and we're going to try and answer them as we go through. And in the meantime, one of the things that we're going to be doing is we are going to encourage you to go to our student activity website, which we're going to put the link to in the chat in a few minutes. And you can do your own tree scavenger hunts or share some of your own thoughts and ideas with the rest of the community on our Padlet. So here's what we're going to do. We'll put the link up there in the chat box or in your comment fields. And you'll have an opportunity to answer those questions and to share any other thoughts about things that you want to do more of. What was your favorite part today? And Cindy and I are super excited to hear about that. And I just want to say thank you for joining us.
Yeah, thank you for joining us, everyone. And thank you, Lindsay, for being near the redwoods today to be able to see the size and to see those redwoods closer with us.
Oh,
So
it was
thank you,
nice.
everyone.
All right, so we're going to turn our videos off, but we'll leave the comments open just for a few minutes so you can keep clicking on that link.